Hello everyone. Today we are going to discuss fine-tuning of a pre-trained model from Hugging Face. So this is the Hugging Face website where you can find a documentation and look deep into the fine-tuning of a pre-trained model. Uh, Now I'll move on to the code where I'll explain what is fine-tuning and how we are going to train the model, train the data set. So basically how fine-tuning works is that you need to load a model, pre-trained model. I'm using DistilBERT here, which has been trained on general purpose. The next thing is that you should prepare a task specific dataset. You need to label a dataset for a specific task. For example, here I'm using spam versus ham for spam detection. Pre-process the data. That is, we are going to use tokenization and padding. Then we need to modify the model at specific task layers. Example, classification header for spam detection, freeze some layers. Then we need to train on the new dataset. That is, we are going to use specific task dataset to fine tune the model weights for the desired outcome. Uh, for example, let's take fine tuning DistilBERT for spam detection. So here DistilBERT already understands English grammar, okay, and sentence structures. Fine tuning on spam dataset would be labeling the dataset into spam or ham, as you can see here. Then the outcome that we would receive here is, after fine tuning, is the model specializes in spam detection while still leveraging its general understanding of the English language. So for example, if the input is win a free iPhone now, the output would be spam. But if the input would be, hey, are you free to meet tomorrow, the output would be ham. So similarly, now when should we use fine tune? When should we fine tune a dataset? Like if you want to perform some custom tasks. For example, if you have a domain specific task like legal document analysis or social media sentiment analysis, that time you should perform fine tuning of that dataset. Also, when you have limited data and if you want a performance boost into your specific task, then at that time you should fine tune your dataset. Okay, let's move on to the code now. So first, I'm importing the pandas library, and then I'm reading the dataset, which is in .csv file, .csv format. So here label and message. A label indicates whether a message is ham or spam, and the message column contains the actual text of the message. Yeah. So moving on, this df shape checks the dimension of the dataset. As you can see, we have two columns and the number of rows here. This x is equal to list df message contains the text message, whereas y contains the label ham or spam label. Next, we are going to split the dataset, and so splitting the dataset into training and testing subsets. So as you can see, test size reserves 20% of the data for training, and random state ensures reproducibility. So X train and Y train are for the training features and labels, whereas the X test and Y test are the testing features and labels. Now moving forward, we need to install transformers library in order to import the trainer functionality. So once that is done, we need to again import DistilBERT tokenizer in order to use this DistilBERT based model. So this snippet basically loads the pre-trained DistilBERT tokenizer for tokenizing text data, and The tokenizer breaks text into tokens and maps them to DistilBERT's vocabulary. So once that is done, here in the training encodings, we are going to convert text into numerical format that the DistilBERT model can process. So basically truncating means truncating text exceeding the max limit. I think the max limit is 512 tokens. And padding means pad shorter sequences to the same length. Train encodings and test encodings, they are tokenized inputs for training and testing. We are going to check the y underscore train, what is the value. So as you can see, 0, 0, 0, 0. So this is the value when we run that snippet, when run y is equal to. Yeah, and after that, we are going to import TensorFlow. And basically, the purpose of this is to convert the tokenized data and labels into TensorFlow datasets for compatibility. And dict train encodings. This provides a tokenized text, and the y-train provides the labels. Similarly, for this, the text encodings provides the tokenized text, and the y underscore text provides the labels. Now we are going to load the pre-trained DistilBERT model. So here, as you can see, we are importing the DistilBERT sequence classification and TF trainer plus the TF training argument libraries from transformers. And once that is imported, we are then configuring the training settings such as pods, batch size, and login over here. As you can see, the output directly, the total number of training epochs, batch size per device, batch size for evaluation, strength of weight decay, directory for storing logs. So once that is done, once we have defined the training arguments, we are going to then fine tune the model. So we are going to import TF trainer from transformers, and I've already executed this code as it would take a lot of time while for execution. That's all. I've already executed the code here. So once that is done, yeah, so yeah, we are going to fine tune the model, and one we are going to import TF trainer from transformers. Then we are going to set the create TF trainer instance to handle training and evaluation, and tf.train. This basically starts the fine tuning process. We are going to pass these arguments here, and yeah, this is the message. This is the output of uh, by which is received using by fine tuning the model. Now we are going to evaluate the model. As you can see, the results are here. Um, yeah. So evaluating the trained model on the test data sets, and this is the output of the output metrics such as loss and accuracy, which we are getting after pre-fine tuning the model. So this is the trainer evaluation. This is the trainer predict. And then this is the shape of the data set. This is the prediction. This is the metrics of the data sets, the confusion matrix. And this is the output for the confusion matrix. Yeah. So that is all about fine tuning. The conclusion is that basically this code performs steps such as processing a labeled data set, for spam classification, prepares the data using tokenization and TensorFlow datasets, fine-tunes a pre-trained DistilBERT model, and evaluates the model's performance on the test set. So that is all about fine-tuning a pre-trained model such as DistilBERT. You can use other models as well in order to fine-tune your dataset. So yeah, that's all about fine-tuning. Thank you.